Yeah, good evening, everyone. Vijay Camps, let's start off. Last class, we are doing this ornament thing. This SHM, time period, pressure, perfect. So let's start with a question. So we have a container here, liquid density 4 rho. We have another liquid here, maybe some oil or something, density rho. And you kept a cube inside like this. Density 2 rho. X part is inside, side is L. Find X in equilibrium. So we have two liquids, 4 rho and rho, and you have kept a cube 2 rho, which is in middle of the liquid. See, because 2 rho can't sink inside 4 rho because it is lighter. It can't float in rho because it is denser. It is stuck in the middle. So find X, where X is the liquid, the depth inside the 4 rho liquid. I hope the question was clear. Two liquids of density 4 rho and rho. We have a cube of side L at the interface. How do we do this? Find X. Others, keep your cams on. Try. 'Any answers?
I just sent mine, sir.
Yeah. Aviksha, your cam is blank. I can't see you. Two L by 3. You get a good number, right? L by 3. Okay. See now, if you draw the free body diagram, This is one liquid here. Let's say this is X. This is L minus X. So there are two bind forces. So the green liquid ka bind force will be rho area, the side L minus X into G. The blue liquid ka bind force will be 4 rho. Remember weight of the displaced liquid L square X into G. And your own weight mg, which is 2 rho L cube into G. Done, na? Balance them. Rho L square L minus xg plus 4 rho L square xg is equal to 2 rho L cube G. Rho G L square G rho L square G. L minus x plus 4x is equal to 12. X is equal to L by 3. Easy? So there are two bind forces, the upper one and the lower one, and then just finish it up. Check. Any doubts on this? All got this? Next one. Turning the page. Can I turn the page? Next one. We have a small ball here. Density rho. We have a liquid here. Density 3 rho. You're dropping it from a height h.
Sir, in
Ball-
the previous question,
Uh,
so you told if lower surface is not covered in fluid, we can't use buoyant force. So,
the lower surface is covered, na liquid.
but it is covered in another liquid, not in the fluid.
Where, what did you say? The lower surface should be covered with one liquid.
Acha, okay.
You only said that statement, Nare. The lower surface should be covered with a liquid. It is covered with one liquid only, na? If
Sir,
it is
but
covered
sir-
with two different liquids, niche, then you can't use. Got it?
Okay. But
Ball
अगर
released from rest.
नीचे अलग है तब चलेगा.
Up and down can be different. The entire bottom surface should be same liquid.
Okay.
Find max depth and the time period of oscillation. So you release the ball from a height of h, density rho, liquid get density 3 rho. So means it can't sink. The ball will fall inside, and then again will come out and fly. You're getting how the motion will go? Find the time period of the motion and the maximum depth it will go.
But now it is water.
Come again. Shaurya.
So the liquid is water.
Why does it matter? Diya na density 3 rho. Density of the liquid is 3 times the density of the ball. Others, keep your cams on. How to do this? See now, what will happen once you go into the liquid? That is the main thing there. So once you go inside, the forces will be mg, which is density of the ball volume into g. I don't know the volume, okay? The bind force will be 3 times the density volume into g, and the acceleration. So the acceleration will be actually upward. Fb minus mg is equal to ma. 3 rho vg minus rho vg is equal to rho into v into acceleration. So we get acceleration is equal to 2g. Means what? Once you enter the liquid, the ball will feel as if you're decelerating with 2g, isn't it? So now if you look at the whole motion here, when you are in the air, acceleration is g. When you are in the liquid, your acceleration is 2g backward. So when you're falling here, the time taken will be root over 2h by g. And at this point, the velocity will be root 2gh. Right? V square minus u square is 2as. So from here to here, velocity is 0. Let this displacement be s. So we are using v square minus u square is 2as. Final velocity is 0. Initial velocity 2gh. 2 acceleration is minus 2g, and s is equal to h by 2. So you travel only h by 2 inside of the liquid. And what about the time? V is equal to u plus at. V is 0. This is minus root 2gh minus 2g time. So time will be root over h by 2g. So done. So what's the total time taken? So from here to here, root 2h by g. Inside the liquid, root h by 2g. While going up again and while going up again. So total time period will be root 2h by g plus root h by 2g ka 2 times. This is a periodic motion. It is not SHM. There is no restoring force proportional to x. Do have a look at the steps what I did. So when you're in the air, acceleration is g. Once you enter the liquid, you're having the ball will behave as if someone is pulling up with 2g.
So it will go back to the same height.
Once you come out of the water, you'll go back in symmetry. No? There is no loss of energy.
Okay.
All clear with this? Any doubts on this? Clear. Next one. Any doubts on this? It's a good one. Basically, it's a kinematics plus NLM time period SHM. So you can say anything. Next one is a good one, right? We have a container filled with liquid. We have a cube here. Side L. Initially, it is at a depth x. Density of the cube is rho b, density of the liquid is rho L, and rho L is greater than rho b, so it will float. Gamma is the coefficient of volume expansion of the liquid. Alpha is the quotient of volume expansion of the cube. So if temperature changes by delta T, find a new x. You're already inside, so your depth x. If you change the temperature, what will happen to the new x? How do you do this? So what exactly happens here when you increase the temperature? Liquid density will change. Cube also becomes big in size now.
Yes.
So side of the cube also will change. इसलिए x भी change होगा. So what to do? Think. I'll give you a minute. It's a good one, right? This will be an advanced में moderate question. Easy to moderate. How do we do this? Anyone didn't understand the question? Please ask. Should I show you? Let me ask you one thing. When you change the temperature, what happens to the mass of the block?
Nothing.
Nothing, right? कुछ फर्क नहीं पड़ेगा mass of the block. So if you see normally now, the new mass of the block will be the new density into new volume. Because generally some people have that confusion, like, you know. So what will be the new density? New density of the block will be rho b plus 3 alpha delta t. That's the volume. What is the new volume? 1 plus 3 alpha delta t. Actually, दोनों cancel हो जाएंगे. You get rho b into v, which is the old mass. Are you getting what happened? The density will decrease, volume will increase, but the product will remain same. Right? So mass will not change. Keep that in mind. So the cube, right? The side will become L into 1 plus alpha delta t. This will be L into 1 plus alpha delta t. The liquid is filled till here, and this will be x. Agreed? So the bind force will be the density of the liquid, which is rho L by 1 plus gamma delta t. How did I get this? If you had revised the notes, you would have seen this. Density of the liquid is rho into 1 plus gamma delta t. Remember this? Because the volume increases, that will decrease by that factor. Into the density will be x into L square 1 plus alpha delta t whole square. and the weight mg will remain same, which is density of the body into L cube into G. Balance them. So rho liquid plus 1 plus gamma delta T into X into L square. You can use binomial approximation. 1 plus 2 alpha delta T is equal to rho B into L cube into G. You'll get X from here will be rho B into L by rho liquid 1 plus gamma delta T by 1 plus 2 alpha delta T. So a simple mains question will be if gamma is equal to 2 alpha, X will not change. They'll ask you this question in the exam directly. What is the condition if the depth inside the liquid does not change no matter how much the temperature changes? Do check it out. Clear with this. The results will be posted tomorrow, and tomorrow the mechanics paper will be online. It will be there till next Tuesday. Fluid mechanics you can start solving. HCRMA, I think first 23, 24 questions you can start. I think there are only 36 questions in HCB. Mostly by Friday we'll wrap up the chapter, I suppose. The statics part is a longer one. Dynamics is easy. Clear? And Saturday there is no class. This Saturday there will be no class. So I'll plan for you guys a little more in the next week. Clear? Next one. Any doubts on the 25th? Please ask. It's a good one. 26. Next one. Let's say we have a like this. We have a cylinder of the cavity. Mass of the body is m. The height is h. Density of the liquid is rho L. So this inside this cavity also is filled with liquid. So the liquid will push this inside like this. Now this is the. So the question is, and this radius is r. So someone removed a hemispherical cavity at the bottom. Find the force due to the liquid on the curved surface of the cavity. Get that? Find the force due to the liquid on the curved surface of the cavity. I hope the diagram was clear. You took a solid cylinder with a cavity. When you immersed it, that cavity is also filled with liquid. Remember, pressure is not constant, right? हर एक point में pressure अलग था यहाँ पे. You can't use projected area. Height is changing, na? Rho g x height. There are different heights. At every point, the pressure is changing. You can't use pressure into projected area. So, what is the force acting on this dome here? This is the question. Right? These are cavity-based problems. Anyone didn't get the question, please ask me. Diagram is clear, go ahead. We did almost 25 questions. Huh? I hope everyone tried all these questions once more before. Definitely after every class, do that. And like a broken tape recorder, I keep saying that every time. It is that important. I would have given a break off actually next week. Pace people are having holidays, but then again, the problem is Pace people are running. The portion is running like mad. It is actually problem with your batch. Your batch now started only 2 months late. The 10th exams got postponed by 2 months. Na? That actually backfired. And dusra, the JEE mains before your batch used to happen in April. Now it is happening in Jan. So we got compressed from both the directions by 2 months. And your batch is special. We are not going according to the pace, but I think minimum to complete. We have to still wind up the portion by November end, right? How to do? See this question, right? Let's do it in 2 things here. First, let's use bind force. Now, if I use the diagram with bind force, what will be the FBD? Tension, your own weight mg, and the bind force FB, which is density of the liquid. What is the volume? Cylinder ka volume pi r square h minus the cavity ka volume 2/3 pi r cube into g. Agreed? Same thing. If I use pressure, remember last time I told you, if you use the word pressure, don't talk about bind force. Now, when I say force on the cavity, that is coming due to what? Isn't it due to the pressure of the liquid? So what are the forces? Tension, P naught into area. This liquid is pushing it, so that is actually a pressure only, which is force on the curved surface and your own weight mg. Are you getting this? This is the FBD for the same body, right? This is the FBD for the same body. Did you observe one thing here? T mg minus T is FB. Here, if you observe mg minus T will be F curved minus P naught pi r square. Isn't the same as bind force? Isn't that the definition of bind force? The difference in pressure at the lower surface and the upper surface is the bind force. Oh, yeah, then answer. So F curved will be how much? F curved will be F bind force plus P naught pi r square. Easy. There is no need to integrate, nothing. So you just draw the free body diagram in 2 ways. You use one bind force and use one pressure. And both are actually the FBD of the same body. That means bind force is nothing but the difference in pressure at the lower and the upper part. So lower ka force aa jayega directly. Have a look at the steps. Please check any confusion here, please ask. This is how you do cavity problems. Huh? Let them give any type of hole at the bottom. You just draw the bind force and pressure and you finish it off. Clear? Try. Next one. We have a water tank filled with liquid. At the bottom, there is a hinge and there's a rod floating out like this. The height of the water tank is L by 2. The rod ka density is rho and the length is L. Liquid ka density is 2 rho. So what will happen? The rod will float, right? Outside. Some part will be outside, some part will be inside. Find theta in equilibrium. Where does buoyancy force act? Remember that thing? Buoyancy force will act on the center of mass of the displaced liquid. I showed you with the diagram also, if you remember last class. Yeah, this is the question. Try. 3 minutes. 2 to 3 minutes. Any answers? How many forces are there?
3 or 2.
3 ना, hinge reaction भी होगा नीचे, God.
Sir, but वो तो उसी से पास करेगा तो उसका तो टॉप 0 ही होगा.
What did I ask you, Shaurya? How many forces are there?
अच्छा.
तो क्वेश्चन सुनो ना रे, एग्जाम में भी वही करते हो. तो क्वेश्चन ना, you don't read, you do whatever you want. Read the question, listen to the question. Forces 3, torques 2. You're not wrong, but that is not the question. See the free body diagram, everyone. So this is the hinge reaction here. The weight mg will act somewhere here, which is nothing but density of the rod rho, area of cross section length L, g. Let's say the liquid is still here. Let this length be x. So the bind force will act at the center of this, which is density of the liquid 2 rho, area x g. This angle is theta. So this is the perpendicular distance. What will be this distance on the center? X by 2, na?
Yes.
So if we take torque about the hinge, should be 0. So that will be torque due to the hinge. Torque about the hinge is 0. So mg ka torque will be mg into perpendicular distance L by 2 sine theta should be equal to the buoyancy force Fb into x by 2 sine theta. Everyone agrees? If you want, I'll just draw that again. See, this is the hinge. This is Fb. Extend the line and drop a perpendicular. No? This is theta. This is theta. and this will act at x by 2, so this will be x by 2 sine theta. Sure, that's the perpendicular distance. Substitute कर लेना values. So rho a l g l by 2 sine theta. 2 rho a x g x by 2 sine theta. X is equal to L by root 2. So in this triangle, if you see, this is L by 2, this is X is L by root 2, and this is theta. Cos theta is 1 by root 2. Theta is 45. Easy? Take the steps. Ask me if you're confused. So basically, the torque due to the bind force and the torque due to mg are cancelling out. Torque due to mg is equal to torque due to bind force. So that is, they're keeping it from rotating outside. Have a look at this. Anyone not clear? Any steps? Trisha, Riddhi, clear? Nishita, Amu? Abhiksha, cams on. Anamai, Ritam, Rishi, Vrinda, cams on. Clear with this?
Sir, one doubt. The buoyant force acts at the center of mass, right?
At the center of mass of the displays, yeah.
So what area did you take?
I took A is the area of cross section, right? Iska area. A is the area of cross section of the rod. That cancels out anyway. Confused?
Yes, sir, a little bit.
This rod is there, na? The rod is like this. Ye tha na area. This is the length. So what is the volume? A into L, na? Understood? Basically, I'm taking this as area. Clear? Next one. This is another standard question. So we have water here. We have an ice cube. It is floating inside. So case 1, density of water is 1 gram per cc. Density of ice is 0.9 gram per cc. Case 2, let's say you mixed up some salt water. The density will be slightly more, 1.05 gram per cc. Case 3, let's say you put some alcohol plus water. The density would slightly decrease to 0.95 gram per cc. So in all the 3 cases, if the ice block completely melts, in which case will the water level, what happens to the water level? If ice completely melts, what happens to H? Increase, decrease remains same. How do you do that? So this thing now, I still remember. I think when I was in school, we went to a movie theater and my mom, I got a Coke for me. So after I got that, what I did, I added a lot of ice into it and I was waiting for it to melt. So my logic ye tha. Once all the ice will melt, I'll get more Coke, then I will drink. So I waited till all the ice melted. Then I drank. It tasted so hopeless, I had to throw it away. So there, you add ice for cooling effect, not to increase the amount of Coke. It doesn't work. It simply gets diluted and tastes hopeless. So don't try that. Get this thing. Okay, case 1, right, Ammu? The case 1 is a standard question, CET bits. Case 2, case 3, I just modified them. Think, I'll get 2-3 minutes. Case 1, water level remains same. Yes. What's happening exactly? See, did you ever hear the statement, whenever this icebergs or something float in water, right? What you can see is only actually 10%. 90% is below the water. That's what makes them pretty dangerous. So look at this. So when you kept the ice block inside here, we have derived this result before X. X is rho body by rho liquid into L. So in this case, it is 0.9 by water is at the 0.9. Meaning whenever the ice block is floating there, 90% is inside and 10% is outside. Okay. So now when you take this ice cube and if you make it into water, what remains same? Mass. Mass of ice will be equal to mass of water. So this will be density 0.9 into volume of ice. L cube will be density of water 1 into volume of water. Did you observe one thing? So whenever this ice melts, it creates only 0.9 L cube water, anomalous expansion. You don't get L cube of water, you get actually less. Now see what happens. If you remove that ice block from there, what you get? You get a cavity, no? What is the space of this cavity?
0.9.
0.9 L cube. How much water you have?
0.9.
0.9 L cube. So if I take this and put it in the cavity, what will happen? It will exactly fill, no? So there's no change. Case 2, what will happen to the cavity? Case 2, the density of water is more. So will it sink more or sink less? If the density of the liquid is more, will it sink less or more? Dekho na, density of the liquid is more. X will be small, right? So this cavity will be less than 0.9 L cube. But the water is still how much? 0.9 L cube. So what will happen? It will overflow, right? Increases. Are you getting this logic, everyone? The cavity ka size is smaller, less than 0.9, but the volume is still 0.9, so water will overflow. Case 3, what will happen to the cavity? More, no? More than 0.9 L. Now in this, if you put 0.9 L cube, you actually get a gap there. So liquid level actually decreases. Is this clear, everyone? Do check it out. It's a good one.
Can you explain case 2 again?
Case 2, देखो ना, this cavity का volume will be less than 0.9 L cube ना. That you understood? ये देखो ना, God, this rho L is 1.05. X will be less than 0.9. Na 0.9 by 1.05 into L. This will be less than 0.9 L. Happy?
Yes, sir, understood.
Anyone else has a doubt on this? Please ask. It's a good question. Easy one, but good one. This is the kind of question you can expect in the exam. Yeah. Next one. Now, if we talk about something called stability of ships. Let's say case 1. So you have a ship here where the center of mass is, let's say, somewhere here. Means mg will act here. And let's say the center of buoyancy is somewhere here. This is center of buoyant force. Now, let's say if the ship tilts a bit due to the water waves and everything, the mg will act here and the buoyant force will act here. What will happen to the ship? How is the torque? Clockwise or anti-clockwise? Fb is this way, mg is this way. How is the torque? Clockwise, no? This will topple over. Unstable equilibrium. If you design a ship like this, it is going to topple over and sink. So whenever you design the ships, what you do, you make sure the center of mass is below. So you have to make the ship heavy at the bottom. That is the reason they keep the cargo, the engine room, everything at the bottom of the ship. So if you see these oil tankers, right, they're very difficult to sink because all that cargo is at the bottom. The easiest ships to sink are cruise ships. Because cruise mein kya hota hai na, these people build tall floors, right? If you've ever been on a cruise, right, people love to be as high as possible. So they have to build more floors. So that actually creates a problem. The center of mass actually shifts upward. Isn't it? So cruise ships have a, like what, 15, 16 floors. So now if the ship tilts, mg is this way, your buoyant force is this way. Can you see? It comes back, stable equilibrium. So that is one. So when you design the ships, you have to make sure the bottom is heavier. Keep all the heavy stuff at the bottom. Check it out. Clear? Next one. Fluid dynamics. So that is about pressure, buoyant force, and Pascal's law. So in fluid dynamics, what we do, we study fluids in motion. So till now, all the fluids that we saw, right, the fluids never moved. Matlab, there is no internal flow among them. The liquids are static. So let's say if a liquid is flowing like this, we take a small part of it and we try to study this. This is called the control volume. So the region of liquid which you are trying to study. So when we study this, we have few things. Flow or field variables. So whenever the liquid is flowing, what variables do you study actually? One, pressure is something which you study. Two, velocity of the particles. Now here, when I say particle, it's a collection of, when you say liquid particle, it is not actually a single particle, it's a collection of molecules. So you don't study single hydrogen molecule, single water molecule like that. You study a collection of molecules. Third, density. The fourth, acceleration. Primarily, we'll focus mostly on pressure and velocity. So we define something called a streamline. What's a streamline? So a streamline is a path of a particle which is tangent to the velocity vector. Velocity vector of the particle at that instant. Let me show you what that means. So if you look at a particle here, I think I taught you something like this in heat transfer. So when a particle is going at point A, the speed is VA. At point B, the speed is VB. So the particle ka speed will keep on changing, but whenever it comes to A, the speed has to be VA. Whenever it comes to B, the speed has to be VB. Do you remember steady state? We defined this in heat transfer. So basically a streamline is the path of the particles. So here all particles reaching A should have speed VA. And similarly, the particles reaching B should have velocity VB. So basically here velocity at a point is constant. Velocity is changing with time, but velocity at a point is constant. Got it? So a collection of streamlines is called a streamline flow. Clear? So what is the streamlines exactly? Let me define in more detail, but have a look at this page. Any doubts on this page? Then see. So at every point, right, if you see the tangent will be the velocity vector. At this point, the velocity vector is this way. At this point, the velocity vector is this way, and so on. Velocity vector is tangential to streamline. That means if someone gives you the velocity vector, no, Vx I cap plus Vy j cap. So at any instant, if you assume this is making an angle theta, we can write tan theta is the vertical component Vy by Vx. And we can also write tan theta is equal to dy by dx, that is the slope. So this thing turns out to be dy by Vy integral is equal to dx by Vx integral. This will give you the equation of the streamline. Example, let's say someone give you V bar is 1 by x I cap plus 1 by y j cap. So if I use this formula here, tan theta will be 1 by y to x by y. So dy by dx is x by y. So y dy is equal to x dx. Integral on both sides, this will be y square by 2 is equal to x square by 2 plus constant. This equation will be y square minus x square is equal to constant. This is a hyperbola. So the streamline equations will look like this. A has velocity VA. Yeah, B has velocity VB. Right, Arishi? That's what you're asking. So this equations will be y square minus x square is equal to constant. So if you actually try to plot this on a graph, I don't know whether you learned hyperbola till now. This thing asymptotes will be y is equal to x. So the streamlines here would be the liquid is flowing like this. This is how the liquid is flowing. The streamlines are like this. You're getting this? So the liquid is coming from left or right and it is flowing like this. It's bending like this. That's how the streamlines. This is actually hyperbola. Rectangular hyperbola to be more specific. You will learn that in conic sections, but got the point? So they can ask you like this, find the equation of the streamline. Do have a look at this page. This you can put the heading equation of streamline. Let me ask you a question on this. Suppose if I give you velocity v is equal to a plus bx I cap minus by j cap. This is the velocity of the particle on a streamline. A and b are constants. Find the equation of the streamline. Check out this thing. Basically, tan theta is v by vx and tan theta is dy by dx. So basically, tan theta is vertical component by horizontal component, and tan theta is also the slope dy by dx, and integrate. Get it? Just as a straightforward integration. Find the equation of the streamline and draw some of the streamlines. Give it a try. Get it? It's just an integration. Try this. I'll just be back in a minute. Any answers? See, tan theta is vy by vx, which is minus by a plus bx. So this is the dy by y is minus b dx by a plus bx. Integral, that will be ln y minus b 1 by b ln a plus bx. Plus constant, bb will cancel. This will be ln y into a plus bx, ln a ln b is equal to constant. So you get y is equal to e power constant is constant by a plus bx. So basically it looks like y is equal to c by a plus bx. This is how the equation looks, where c is some constant. Check the steps. I skipped few steps, directly started writing the result. Do check out that steps. Clear? Now, if I try to plot this graph, y is c by a plus bx. See how it looks, huh? If x is 0, what will happen? If x is 0, y is some constant, right? If x becomes infinity, what will happen to y? 0, no? If x is infinity, y is 0. So this meaning the streamlines are becoming like this. So if I decrease the Sika value, let's say this is C1. If I take C2, where C1 is greater than C2, means if you decrease the constant, what will happen? The streamline will come down a bit, no? So this will be the next streamline. This will be the next streamline. Are you getting how the streamlines are going? C1 is greater than C2 is C3. So if you decrease the Sika value, streamlines will actually come. Similarly, you'll find the streamlines here also. Actually, this is how the liquid is flowing here. Here C is negative. But C is a constant, it could be anything. So this is how the liquid is flowing. It is going towards plus infinity, they're converging, they're getting closer and closer. Clear? And if you observe here, the greater the density, so greater the density of steel lines, more the liquid flow. That means the amount of water flowing per second per unit area is more there compared to here. Greater the density of streamlines. Just like traffic, if you have more people, just congested and trying to go, the greater the velocity, greater the density of streamlines implies greater the velocity. So liquid is flowing faster there compared to that other one. And if you observe one thing, right, the streamlines never intersect. Because at the point of intersection, there'll be two directions. So if you have a streamline like this and this, so at this point, this is also a tangent. At this point, this is also a tangent. How can you have two velocities for the same particle at the same instant? Two tangents will come at intersection, not possible. That's why they don't intersect. Check it out. Clear? Now, this is all great, mathematically and all we're understanding. But if you actually see a streamline flow, how does it look? So this thing, we also have a name. Steady flow, streamline flow, or laminar flow. So all are same. So in this case, what happens, right? It is like a vehicles going on a highway. If you ever observe them, right, it's all like a lane. A car going in one lane. I know Mumbai that doesn't work like that. People just smash everything and go anywhere they want. But technically speaking, right, a car going in this lane will continue to go in that lane. Meaning, if you, let's say you take some ink and if you start pouring on this line, you'll observe only this full line becomes red. The ink will not cross into the other lines. The ink does not spread basically. This you can see on the Eastern or Western Expressway, let's say for some reason, one lane mein car suddenly stops, only vehicles in that lane get stuck. The other lanes are moving. And then people get mad and then they start changing the lanes and doing all goof ups. But yeah, so ink does not spread. So how does the other one look like? This is a non-steady flow, or we also call it as turbulent flow. Meaning there is no logic, nothing there. Anyone is going anything. You can see the Baji market, best example. So in this case, what happens? If you try to put some ink here, you'll observe after some time, right? The whole thing has become bluish. So if you leave a particle, we don't know where it is going to come out from. There's no defined particle. So these are not called streamlines. Best example, where you see this every day. When you open the water ka tap, observe it. Starting part will be crystal clear. After some distance, it becomes hazy. Observe. When you open the water tap, initially the water comes out, now it looks very crystal clear, and then it becomes all hazy. So the starting part is a streamline flow. Then it becomes a turbulent flow.
Okay.
Got it? So who decides whether something is streamline or turbulent flow? So for that, we have a property called Reynolds number. The symbol is R. This Reynolds number is given by rho V d by eta. So if you have a pipe, d is the diameter. So liquid is flowing. Let's say v is the speed. Rho is density, and eta is coefficient of viscosity. So experimentally proved quantity, this is if the Reynolds number is less than 2000, it is a steady flow. If Reynolds number is between 3000 to 2000, we have no idea. It can be anything. Sometimes it is turbulent, sometimes it is this. Reynolds number greater than 3000, it is definitely turbulent. So this is all experimentally derived data there. So exam they asked a question, for a liquid to flow in a streamline flow, which of the following should be valid? High viscosity, high density, low viscosity, low density, high viscosity, low density, low viscosity, high density. Like that, 4 options you have. So for a liquid to flow in a streamline flow, should you have high density or low density? High viscosity or low viscosity? Tell me.
High viscosity, low density.
So basically what you want to find, for steady flow, R should be small, no? Meaning you want the denominator to be small and numerator to be small and denominator to be big. Right. So we need low density and high viscosity. Fluids, right? A streamline flow. Meaning they have a higher probability of being in streamline. This was a direct question in the exam. Huh? Check. Clear with this? So if you look at this, see what is doing now. Actually, there are 2 streamlines inside. He's sending ink from the left side and he's changing the speed. So if you increase the speed, what will happen to Reynolds number? Increase, right? So by increasing the speed, the flow becomes turbulent. By decreasing the speed, the flow becomes streamline.
He was saying, look at the white at the top. Yeah.
And then you'll see when it's laminated.
That's
I see.
So right now it's transitional.
Oh, it's literally mixed throughout the whole fluid, but when we see that
So
line,
that the dye is in there right now. It's just it's just blue. The whole thing. When you see that line, that means it's completely unbroken.
yes, and you can kind of tell by how clear the water looks.
And if you look at the very top, that looks like a complete tube with no motion at the top of that flow and the bottom as well. When it's turbulent, you'll see like a white speck, a reflection kind of speckling. And
What's the height?
दिख रहे the streamlines? So when the flow is less, you can see clearly two streamlines, right? They're following that, but they don't get mixed up. Now, if he increases the speed, look at to the whole color, everything will become bluish. You can. I hope you can see this two streamlines.
But there will be one only. No? Once.
नहीं, ये लोग actually दो streamlines छोड़ रहे हैं अंदर.
अच्छा दो तरफ से okay.
हाँ, there are two streamlines inside. वो लोग दो color छोड़ रहे हैं. You can see this is more clear actually.
with the strobe.
And now, if you increase the speed, right, it becomes turbulent. You can see the whole thing become bluish. The color got spread over everywhere. ये पूरा turbulent हो गया था flow. Is this clear, everyone? So this is what I mean by that. And that is one. And there is something interesting I saw recently. I think this is one more that I'll show you that. See, this is how they release ink inside. You saw on the left hand side, there's a small nozzle kind of thing. So the ink is being released from there. You can see the streamline.
The pump's not on. Is it? Trying to get little.
Now see, they're increasing the speed of the water. You can see it becomes wobbly.
Keep it there and we'll turn it on. Okay, I'll keep it.
If you keep on increasing the speed, the flow starts becoming turbulent like. Can see how it is spreading off? The flow has become turbulent. This thing I saw, this is a good one. So someone actually wrote a program on this thing. How to solve a maze. We play na normally वो times of magazine में आता है ना maze.
Yes.
So the question is, if you make a maze like this and send water, can the water solve the maze? Obviously, na, see, because there's only one entry and one opening. If you send the water, that has to come out from that only. There's no other way.
This is the kind of thing that I would make for real. So, of course, when I saw it, I had to make it for real. I actually made it for me.
So this is basically actually a computer program. Now, computer program, what happens, right? See, a computer AI, what it does, it will take every possible path. So if you actually give a computer program to fill it, it will just fill up all the tanks.
Any wrong Joe's turns. Just trying to push it all in the description. Okay, so here's the fill up.
So on the right hand side, you can see that's a computer program. So this guy actually made a physical maze.
Completely with water, and it's very satisfying. But if you want to see that ending, you'll have to go to Bergman Joe's profile, link in the
I'll post
description.
this in the
Okay, so
group
here's
anyway.
the simpler maze first. Then what we find brilliantly is that the water simply solves the maze without taking any wrong turns at all. And actually that makes sense because
Can tell you why it is doing that directly. कोई दूसरा path क्यों नहीं ले रहे? हाँ, Shauti? Because water. Because water is
Change
smarter
in pressure.
Change in pressure. I thought someone will say water is smarter than humans. Then change in pressure क्या होता है रे? The question, see, water is coming down. Why didn't it go on the left hand side? वो starting जब नीचे आया था, did you see? It just took a path there. Why didn't it go to the left? See that again. See how it went.
simpler maze first. Then what we find brilliantly is that the water simply solves the maze without taking any wrong turns at all.
It didn't take a
And actually
single
that
wrong
makes
turn.
sense because every time
Q? Anyone? Why didn't it take any wrong turn? See, normally the water should have gone every direction, then should have come out. But here it didn't take a wrong turn anywhere. Think about it. If it takes a wrong turn, the wrong turn is a closed space. If the liquid has to go inside, the air will get compressed. So that air pressure is pushing it out. It is not letting the air, water enter inside. Because if the liquid tries to go in that space, the air will get compressed and the pressure becomes greater than P naught. It is pushing it out. The only entrance where you can go is that one which has a hole, na P naught. Air can escape through that hole only. Are you getting the logic there? So when the water is filling up, the only space where the air can go out is that entry exit point. Remaining all spaces are closed. If the water tries to go inside, you have to push the air outside, but air can't go, right? There's only one way in. There's no exit. Is this clear, everyone? So basically, that is how the maze solves. But later on, if you make a thinner maze, it has multiple issues called surface tension. Sab aayega.
Bigger laser cutter maze is that mazes are always made of two separate pieces. I mean,
It's an interesting one.
Clear and keep walking forwards, and you'll eventually the pressure of water from the tank just slowly starts to creep into those stagnant areas. So there you go. Water
I'll post this. You can watch it. It's a 10-minute, but I found it pretty nice. That was one. This thing, I'll show you this. Later on, we can discuss about this. How does an ant colony look like? You must have seen ant ka nest, right, on the ground. Sabko lagta hai ant nest, how it must be like hill or something. So what this guy did, and it's a cruel thing, but for the greater good of science, he took molten aluminium and poured into an ant ka nest. The poor ants, they died. Almost, I think, 400-500 degrees, molten aluminium. More, I don't know the melting point of aluminium. So there we got a volcano kind of thing. Then he removed it. So whole thing will get solidified, right? Generally, people underestimate, the ant ka nest ka size and all. See how big it is. This is how it looks. Saw that? There. That is how an ant nest looks inverted. So this is, I think, and this is the right direction, up to bottom. That is how the ant nest looks. Total weight is 79 lb. I think roughly around 9 kgs. Nice, no? You can actually make designs. Array, that last thing was good weight. I think he polished it and cleaned it properly. The finished final one looks like this. There, that is a cruel art by killing ants. But yeah. Clear. So there we got the meaning of turbulent flow. We'll talk about the ants later on. Why ants actually build that nest, like they build towers.
To get more
space. Mumbai nahi hai re. When space underground. Mumbai mein space nahi, so we build towers. So what we do, right, while studying fluids, so we'll be studying streamline flow for ideal fluids. So we will just limit our study to very specific cases. For ideal fluids, what are ideal fluids? No viscosity, means there is you can conserve energy. There's no friction basically. Viscosity is nothing but friction in liquids. The liquids are incompressible, means no matter how much pressure you apply, the liquids don't compress. In real life, they do compress, so density changes a bit. We are assuming rho is constant. The liquids are irrotational. Meaning, did you ever see water when it is flowing, right? You see small whirlpools. like this. So we are assuming there are no whirlpools here. So this condition for this thing now, for irrotational flow, this is little slightly off topic. You have done something like this in work power energy, for conservative forces. We say del cross V is 0. D is a curl operator, which is minus dou by. Remember, for conservative forces, del cross F is 0.
Yes, sir.
Minus dou by dou x I cap, minus dou by dou y j cap, minus dou by dou z k cap. This is called curl operator. Just a basic idea, I know that. So meaning del cross V matlab I cap, j cap, k cap, dou by dou x, dou by dou y, dou by dou z, vx, vy, vz. This del should be 0. That is the condition for irrotational flow. We use something like the same for conservative forces also. Okay, so we'll be studying primarily liquids without viscosity, incompressible with same density, and irrotational flow. So in fluid dynamics, right, we have actually 3 concepts. One is this streamline flow, and second thing is equation of continuity and Bernoulli's theorem. So Bernoulli, right, we'll skip the derivation, it's not important. HSE it is there, but we will see later on for HSE part. Equation of continuity is same as law of conservation of mass. What it says is liquid entering is equal to liquid leaving. So if you have a pipe like this, let's say area is A1, area is A2, you are coming out with B2 and you're entering with B1. If you take a small cross section here, dx1, small cross section here, dx2, mass entering is equal to mass leaving. So we get density rho1, A1, dx1, that is a volume, is equal to rho2, A2, dx2. Rho1 is equal to rho2 because the density does not change. We get A1 dx1 is equal to A2 dx2 divided by dt. You'll get A1 V1 is equal to A2 V2. This is also called as volume flow per second. So if someone asks you how much water is flowing out of the pipe, it is simply area into velocity. This equation is called equation of continuity. Now, if you imagine, right, you must have played with the water tap. If you close half of the water tap, what happens? Speed increases. That is because of this. If area increases, velocity decreases. If area decreases, velocity will increase. So this is what happens with your water tap. And something similar happens with your, your arteries and veins in your body, right? In the legs, arteries and veins in your legs are thinner compared to the arteries and veins in the upper part of the body. Same reason, because the arteries and veins are thinner in the lower part of the body, speed of the blood is more. So the blood flows in the upward direction with more speed. You have to go against the gravity, right? So that is the reason, arteries and veins are thinner in the lower part of the body. If we close the tap, then the liquid flow with infinite velocity. There's something else happens. So you're talking about a molecular level thing. As A tends to 0, we will tend to infinity. The moment you close it, right, then the whole definition goes wrong. No? There is no liquid flow only, right? The moment you close the tap, there's no liquid flow only. So your whole definition goes there. You can't talk only about it. तो होता है, people do say jokes, can't help it. ठीक है, clear with this? So let's see some questions on this. Let's see an easy one, and then we will take it up. We will start working. Friday we'll wrap up the chapter. And we'll start viscosity introduction also. Viscosity is a very small chapter. We barely have 7-8 problems. So let's say we have pipes like this. Let's say this A1 is 20 centimeter square, entering at a speed of 10 centimeter per second. This A2 is 5 centimeter square. Let's say this is V2, which I don't know. A3 is 10 centimeter square, and here the liquid is flowing out at a rate of 60 centimeter cube per second. But speed V3, we don't know again. So you don't know V2, you don't know V3. Find V2, V3. Try. Basically, this is what happens when two rivers meet. They say no, the Prayagraj or somewhere the two rivers meet and they combine into one. So basically, the flow rate is that. The flow rate will add up. Net inflow is equal to net outflow. In current electricity, we call it junction law. The current entering a node is equal to current leaving the node. Answers. See now here A3, V3 is 60. A3 is 10, so V3 is 6. And we also know A1, V1 inflow is equal to A2, V2 plus A3, V3. This is 200. This is 5V2 and this is 60. So 5V2 is 140. 28 centimeter per second. Right? Easy? Clear? Any doubts on this? Any doubts on this? Anamai, clear, na? Nishita? Sure? Amu, clear, na? Trisha? Arishi? Labdi? Next one. We got a building here, 20 meters tall. Here you have a water ka jet. Area of cross section is A. And you're firing this water here like this with a speed of 10 meter per second at an angle of 60 degrees. So what happens to the area of water jet? Options will be increase, decrease, increase, decrease, and decrease and increase. What happens to area of water jet? Find the maximum area. Find the maximum area of water jet and the area when it hits the ground. Find the area of cross section when it is about to hit the ground. Initial area is A. Get it? Equation of continuity, projectile motion. I hope the question was clear. You're spraying a water jet of area of cross section with 10 meter per second at 60 degrees. What will happen to the area of the water jet as it flies and comes down? Will it increase? Will it decrease? Increase and decrease, decrease and increase. Find the maximum area. Through the entire motion, where is the maximum area you get? And what is the area of the water jet just before hitting the ground?
Sir, increases and decreases.
Increases and decreases. Right, Harsh. You got that right. Get the rest. Any answers? So you need to think of like this, Resina. Area into velocity is constant, right? What happens to the speed of the water jet? As it is going up, when the speed decrease? And then while coming down, speed will increase. The speed of the water jet will decrease and increase. Na? So area will increase and decrease. Speed of water jet decreases till H max and then increases. That means H max may get maximum area. For a root 71, वो इतना bad answer नहीं आएगा रे हर्ष. So the water jet, if you see now, it actually first becomes big like this. Then it starts thinning out. So at the highest point, you get the area. Speed is how much? U cos theta, which is 5. Let this area be A dash. This area is A and the speed is 10. So A into 10 is equal to A dash into 5. So the maximum area will be double. What about the speed when it hits the ground? Let this area be A2 and that is V2. How to find V2? Conservation of energy, people. State 1 and state 2. You can conserve energy, na? Energy in state 1 is equal to energy in state 2. Initial energy half m u square plus height will be mg 20 is equal to half m v2 square.
So projectile से निकालेंगे.
Projectile से करेंगे problem क्या आएगा? You have to find vx separately, vy separately, and then you have to square and add them. It will become long. आएगा answer, but it will become long. कितना था ये? This is 10 root 5. So a into 10 is equal to a2 into v2. So A2 will be A by root 5. Check your answers, everyone. It is simple work per energy conservation. You just need to find the speed just before hitting the ground and you put A1 is equal to A2 V2. Harsh, check karo, where did you mess up?
Sir, when the water reaches the end of the projectile motion, like if you draw a straight line from 20 meters, the like the horizontal component will be 5 and downwards the vertical component will be 5 root 3 by 2, right?
Vertical component calculate करना पड़ेगा रे. Vy square will be uy कितना होगा? 5 root 3 whole square minus plus 2 minus 10. Height is also minus 20 ना? We both are minus axis. Speed बढ़ेगा ना? You take only one minus you took, I guess. All got this? That is about equation of continuity. Bernoulli's equation. Just finish off the theory part. Friday we'll do more problems. So basically Bernoulli's equation, right, is valid for a streamline. And this is another form of law of conservation of energy. CET level question. Huh? Bernoulli equation is what? Law of conservation of mass, law of conservation of momentum, law of conservation of energy. That was a CET level question. That's what I keep saying. CET it is easy to score, but cutoffs are high. Even to get into a college like VJTA computer science, you need to put 185 and plus. On the other hand, right, the other colleges cutoffs are mains mein cutoffs are low. So for this, like I said, we'll skip the derivation part. We'll get just as a result. So if you have a pipe, right, where the liquid is flowing here. Let's say the liquid is entering with V1, leaving with V2. Area is A2, area is A1. At this point, P1 is the pressure. At this point, P2. Let this height be H2 and let this height be H1. So basically the liquid is flowing like streamlines here. So the Bernoulli equation, right, what it says, if you take 2 points, P1 plus rho G H1 plus half rho V1 square will be equal to P2 plus rho G H2 plus half rho V2 square. So basically this quantity P plus rho G H plus half rho V square is constant. P is the pressure.
So basically you equated the pressures at both ends.
No, actually क्या होता है ना, the work done by pressure is equal to change in kinetic energy plus change in potential energy. We have to use work energy theorem. Both the sides the pressures are pushing the liquid. Because of that, the height and the kinetic energy change. वो derivation important नहीं है. So pressure at a point. H is the height of that point above the reference. I'll write on the next page in more detail. V is the velocity of the liquid at that point. So these three ka sum rate is always constant for a streamline. So let me just write it down again. So P plus rho GH plus half rho V square is constant. We'll see applications in the next class on this. So in HEC book, they call this thing pressure head. This is called potential energy head, or simply potential energy per unit volume. That is the meaning of head. Because see, if I multiply volume, what will happen? Density into volume is mass, no? It is actually mgh. So this is potential energy per unit volume. This is also called as kinetic energy head, which is nothing but kinetic energy per unit volume. This is actually work done by pressure per unit volume. This is good, but there is actually a better form of this. There's even a more powerful form like this. Let me show you that. But remember, this is valid for any 2 points on a streamline. You can't apply from wherever you want. Now, the other form of this thing for gases. Let's say the gases are flowing in a streamline flow, something changes in the formula. P plus rho g h plus half rho v square plus U by V. U is the internal energy. Because whenever the gases flow, temperature also changes, na? So you have to include that internal energy also for a streamline thing. This is internal energy per unit volume. So basically use this formula whenever the temperature of the liquid is changing or temperature of the gases is changing. Generally, when the liquids flow rate, we assume the temperature does not change, so it wouldn't have mattered. Use this when temperature of the liquid changes. Have a look at this. So these are the two main formulas. We will do questions based on this. Both the cases we will see.
Sir, but at a fixed temperature, internal energy will be same only, no? So we can.
So इसीलिए इसको नहीं लिखा ना यहाँ पे God.
Okay.
That is the reason. Na normal Bernoulli में तो we didn't do anything. This is a modified Bernoulli.
Okay, sir.
So Bernoulli equation को भी modified it.
Means when this increases, something of the other three will decrease.
Yeah. But we will do a problem on this. We'll do some little basic one. Clear? Let's do just one question and we'll wrap up. Bernoulli equation questions we'll do in the next class. Let's say we have a pipe like this. Let's say area is A. The liquid is entering with V. There is no gravity. So this is a top view. This is on a floor. This is also area A and the liquid is coming out with V. So liquid is entering and coming out with this. So can it tell me like in what direction does it move and which direction does it rotate? In what direction does the pipe rotate? The liquid is entering and leaving from a Z-shaped pipe here. So when the liquid enters and leaves like this, something happens. The pipe will start rotating, and the pipe.
Sir, anti-clockwise.
Okay. Others think I'll give you a minute. Let's see. Someone said something anti-clockwise. Okay. Do you guys remember this water jet ka force formula we derived? So if you have a water jet like this, going with speed V, density rho and area A. So when this comes and hits the wall will experience a force of rho a v square. By Newton's third law, the pipe also will get pushed back with rho a v square. No? So when the water is entering in the forward direction, it will push the pipe backward by rho a v square. So if you look at the shape here, so the liquid is entering like this. So it will push the pipe forward rho a v square. When the liquid is going down, it will push backward with rho a v square. When the liquid comes and hits here, rho a v square. When the liquid is leaving, it will push back with rho a v square. You're getting how it is pushing? So when you go front, you'll push it. When you're taking a turn, you'll push the wall backward, no? So if you look at the net force here, this will be the force rho a v square root 2. This will be the force here rho a v square root 2. Both are couples actually. Matlab net force is 0, but they will rotate which way? Clockwise. F net is 0, but there is a torque. We have two equal and opposite forces with a distance between them. Clear with this? So the whole setup will try to rotate clockwise direction. Great. So yeah. So make sure to go through this. We did almost 31 problems. So next class on Friday when we meet, we'll continue with the equation of this thing, Bernoulli's equation. In Bernoulli's equation, we have four concepts: velocity of flux, aeroplane wing, Venturi meter, and siphon. The velocity of flux is the most important one. It has some 4 or 5 models. The remaining 3 are theoretical: aeroplane wing, Venturi meter, and all are theory. I just have to show you the main formulas for that. So not much is left. I think we'll finish off in the first half, and second half we can do viscosity little introduction. Okay, so with that we'll wrap up for the day. So I'll see you guys on Friday as usual. So any doubts, anything, please stay back and ask, or also free to leave.